World record run by diesel car, Nardo, 1978. In 1976, as part of their continuous research into the fuel economy and exhaust emission characteristics of diesel cars, Daimler-Benz broke 16 international Class 8 records and 3 world records. The next stage was to test further methods of increasing performance while improving fuel economy. Countless body designs were produced and 1 to 5 scale models were made of the most promising ones in the process of taking the decision to develop a new test car. Wind tunnel tests with the models showed that a lower drag coefficient than that of the previous car could be achieved. When it had been decided to go ahead with the project, a full-scale model was made, initially for wind tunnel tests. Large surface radiators to make sure that engine components were kept at optimal operating temperatures. The 5-cylinder engine was the obvious choice for the basic power unit. It is a well-proven engine of which thousands have already been produced, and in 1976, experimental turbocharged versions had already produced 140 kilowatts. Further development enabled its output to be raised to 170 kilowatts. Testbed running preceded the installation in the car. In series-produced engines, the emphasis is on long life. But it was clear that for the engine to produce twice the power of the 3-litre turbocharged engine used in the 300 SD from the same cubic capacity, it would have to withstand extremely high stress. Some parts of the turbo compressor ran red hot. Test runs at Nardo largely confirmed the calculated theoretical performance figures and provided valuable information on the continuous stress on various components. It was clear that the objectives were within reach. When the car touched 300 kilometers per hour for the first time, it gave further information, which led to some further modifications. Finally, on April the 29th, the intensive preparations for a 12-hour endurance run were complete. It was carried out by staff from the development department, ex-racing drivers, now motoring journalists, Rico Steinemann and Paul Frère, and Daimler-Benz test engineers Dr. Hans Liebold and Guido Moch. The start. Speed measurements confirmed the expectations. Pit stops. Refueling, topping up the oil, changing drivers, cleaning the windscreen. The car covered lap after lap at 325 kilometers per hour. At each refueling stop, 140 litres of fuel were put in, enough for 2.5 hours at maximum speed. Fuel consumption was less than 16 litres per 100 kilometres, unprecedented fuel economy at such speeds. But this performance is more than simply an interesting and spectacular byproduct of Daimler-Benz's unceasing development work towards fuel saving in production cars. At night, the run continued at the same speed. Minor routine servicing was carried out regularly. bad weather did not help. Morning mist reduced visibility and demanded utmost concentration from the drivers. So, for safety reasons, driver changes were more frequent. While drivers changed over, headlamps and windscreen were cleaned. After 12 hours, the objectives had been achieved. A diesel-engined car had broken 9 overall world records previously held by petrol-driven cars. The average speeds were 316.484 kilometers per hour over 100 kilometers, 319.835 kilometers per hour over 100 miles, 321.860 kilometers per hour over 500 kilometers, 320.788 kilometers per hour over 500 miles, 318.308 kilometers per hour over 1,000 kilometers, 319.091 kilometers per hour over 1,000 miles, 321.843 kilometers per hour for 1 hour, 317.796 kilometers per hour for 6 hours, 314.463 kilometers per hour for 12 hours. So Daimler-Benz now hold 12 world records for C111.2 and C111.3. But these peak performances are no more than an interesting, if rather spectacular, byproduct of the continuing development work being done by Daimler-Benz in their search for ways of saving energy in production car manufacture. Here, low consumption and environmentally acceptable engines and also bodies with an aerodynamically effective shape are becoming more and more important.